In the next series of videos, we're going to do some practice problems related to the concepts that we saw in the previous video. So let's start with the first question here. What is the overall rate of production of nitrogen dioxide in this reaction here? 2N2 plus O2 produces 2NO2 gas if the concentration of nitrogen dioxide changes from 0.32 moles per liter to 0.80 moles per liter in 3 minutes. So this depends on what the question is asking for in terms of units. We were given this in minutes. You could have been asked to do the rate in moles per liter second, and if you were, all you would have had to have done was convert this minutes to seconds first by multiplying by 60. I'm going to go and use the minute unit, but then afterwards I'll just show you what it would look like if you did the second unit instead. So we know that we're looking at an average rate here, an overall rate. It's an average rate between two time intervals because we were given two concentrations here. And then it says in 3 minutes. And that's a confusing part. Students don't quite understand, where's the other time interval? Well, that is the time interval that was done. The change in time was already done for you. So it might have been 0 to 3, for example, or it might have been, 23 to 26. But either way, that was the time interval. Within that 3 minute time interval, what is the rate of nitrogen dioxide production? So we are looking at products over here. Since we're looking at products, we would expect our number to be positive right off the bat, no negative values there at all. So we want to find the rate of, so change in the rate is going to be equal to, so rate is equal to the change in the concentration of NO2 over our change in time, over a delta T. So we have an increase in concentration, which makes sense because it is a product. So we have our Y2 essentially. So our our final concentration, so 0.80 moles per liter minus the Y1, which is 0.32 moles per liter. So I'm just going to put all this here like that and put moles per liter outside there because that's our final unit in the end for the top part for the numerator. And then over the delta T, which is given to us as 3 minutes here. So over 3 minutes. And so that's going to be, so you do your 0.8 minus 0.32, and then we'll do divided by 3, and we get 0.16 moles per liters minute. Now, if you were to go with 1 sig fig, then you would do approximately, because there's a 3 minutes is 1 sig fig there, 0.2 moles per liters minute. And that is if the question is asking you for the rate per minute. If you want to do this per seconds, what you would have done first, you would have multiplied the 3 by 60, and you would have got that you have 180 seconds because there's 60 seconds in a minute. So it would have been the same process here, same process. Now the question didn't ask this, so that's why I'm doing it as an aside without all the work there. So you'd have your 0.8 minus 0.32, which is your 0.48 moles per liter over the 180 seconds. And that would have been divided by 180, 0.0026, 0.00266, and it keeps going, moles per liters second. And you would still go with the measurement given here, 1 sig fig, because that's what you were given as a measurement there. So approximately 0.003 moles per liters second. If you were asked to do that in seconds rather than minutes. But in this case, you weren't, so you just leave it in per minutes. So what we did there is we simply calculated the rate of a reaction using the production of one of the products, the NO2, using data provided to us. So there was no graph that we had to look at here. Basically, they took the data from the graphs for a 3 minute time interval, and they gave us those concentrations, and we just had to go and plug them into our, essentially what we did is we have a final So this is our final concentration minus initial over your change in time. And that gives us our rate of reaction over here in terms of the production of NO2. So in the next video, we're going to take a look at how to do a similar problem, but using graphs instead.